All right, I hope example 3 and example 4 went well, but let's go ahead and take a look. So we needed to graph in example 3, f of x equals x cubed divided by 2 minus 1. Okay, we recommend make a table of values. Okay, so we chose -2, -1, 0, 1, and 2. You need to plug those in for x and get values for y. So when I plug in -2, -2 cubed is -8, divided by 2 is -4, minus 1, and it equals -5. So again, evaluate the function for each of those 5 values, and it should result in the following ordered pairs: -2, -5, -1, -1 and 1/2, 0, -1, 1, -1/2, and 2, 3. So I went through and I plotted each of those points. So I went left 2, down 5, left 1, down 1.5, 0, -1, okay, right 1, down 1/2, and right 2, up 3, and I connected those lines to create the blue curve. Now, is the blue curve a function? Yes, it is, because it passes the vertical line test. Is it a one-to-one function? Yes, it is, because it passes the horizontal line test. Okay. Therefore, since it's a one-to-one function, I am going to switch the x and the y's and solve for y to find the inverse function. Okay. I begin by adding 1 to both sides, so we have x plus 1 equals y cubed divided by 2. Then I multiply both sides by 2. And just as I did before, you multiply the entire quantity by 2. So on the left side, I distribute the 2 to get 2x plus 2. On the right side, I have y cubed remaining. To get rid of y cubed, you take the cubed root of both sides. So we have the cubed root of the quantity 2x plus 2 equal to y. And then I replace the y with inverse notation, which is f inverse of x, f to the -1 power of x. And it's equal to the cubed root of the quantity 2x plus 2. Now, when I start thinking about graphing this, I need to be very conscious of the values I'm plugging for x, so I get relatively nice values for y. Well, off the top of my head, that's going to take me a bit of thought to do that. So I'm going to start thinking about this numerically. Okay, I have a table of values up here, and I have 1, 2, 3, 4, 5 ordered pairs. Well, remember, with a set of ordered pairs, how do you find the inverse? Well, I switch the x and the y. So guys, all I'm going to do, rather than trying to think up the values of x and plug it in, and calculate it, and get a value for y, I'm just going to switch the x and the y's for the ordered pairs that I already found. So that means, okay, my table for the inverse function is the ordered pairs from above switched. So the first ordered pair in letter A was -2, -5, so I have -5, -2. And I had -1, -1.5. I just flip those and make -1 and 1/2 and -1. I had 0, -1, so I flip those, I have -1, 0, and now I have 5 ordered pairs for my inverse function. There are times when it's much easier to just use your table of values, switch the x and the y's, and then you can plot points to make it the curve for your inverse. So when we plot the points -5, -2, go left 5, down 2. Go ahead and plot the remaining 4 points, and you're going to see that we also have a pretty nice curve. Okay, so go back above. Okay, your curve is kind of like an S curve. And we know we did everything correctly because my 2 curves do reflect across the line y equals x. That means that I have accurately graphed my function and its inverse. Example 4. Okay, in example 4, we have f of x equals the square root of x minus 1. When you start graphing curves, you need to start thinking about domain. This is a square root function. So if I want to find the domain, I set what's under the radical greater than or equal to 0. So that means x has to be greater than or equal to 1. So when I'm plugging in values for x, the smallest number I can plug in is 1. Otherwise, I'm going to get a negative underneath the radical. So if I plug in 1 and calculate, I get 0 for y. If I plug in 5, I get 2. And if I plug in 10, I get 3. And here I have the curve in pink of the square root function in letter A. Now, is this a function? Yes, because it passes the vertical line test. Is it a one-to-one function? Yes, because it passes the horizontal line test. Okay, guys, in all of our previous examples, the domain was all real numbers. Okay, that is not the case for a square root function. So we need to identify the domain and the range. So my domain, my x value starts at -1. It can be -1 and it goes to infinity. Okay. My range, y values begin at 0, and these will go up forever, so from 0 to infinity. So when I start thinking about my inverse function, because it passes the horizontal line test and the inverse function exists, I have to keep in mind the restriction on the domain and range. So the domain of my original function becomes the range of the inverse. The range of the original function becomes the domain of the inverse. Now, why is this important? You should have gone down and found the equation for the inverse. Okay, you switch the x and the y. We have to square both sides to get rid of the radical. So we have x squared equals y minus 1. Add 1 to both sides. So f inverse of x is x squared plus 1. What shape is the graph? Well, the shape of this graph is a parabola. It's the graph of x squared shifted 1 up 1. The problem is that there has been a restriction on the domain. The domain of the inverse has to match the range of the original, which is everything x is greater than or equal to 0. So we have to eliminate the left side of that quadratic function due to the restrictions of the domain and the range. Now to find values to plot, again, I would just take the table of values from letter A, switch the x and the y. So I have the ordered pairs 0, 1, 2, 5, and 3, 10. Okay. And notice if you plot those points, 0, 1, 2, 5, and 3, 10, you have your inverse function that reflects across the line y equals x.